Okay, so scientific notation. The key to it is this, and if you can do this process, you'll be fine every time. Let me scooch that over. If you can do this process, you'll be fine every time. So the goal is, if you're trying to get it into scientific notation, the format is it's gonna be a number between 1 and 10 up front. Okay, so that's gonna be a number, and that number has to be between 1 and 10. Okay, and then you're gonna do times, and we're gonna write times old school with an X when we're in scientific notation, for the most part. Sometimes they'll do it with like a dot, but the acceptable way of doing it, if you're doing it properly, is to put an X for times. So it's a number between 1 and 10 times 10, and then you're gonna put your power or your exponent up there. That's gonna be the format of everything that's in scientific notation, okay? And the key is, once you figure out what this number is, the power that's up here is your way of mapping it back to the original number. So if the power is a negative number, that means that to get back to the original, you have to move to the left to get to the original. And if the power is a positive number, that means to get back to the original, you move your decimal place to the right. So scientific notation is just a mapping back to the original number that follows this format. So for example, number 1, they give us a bunch of zeros and then 199. So based on this, my number that's between 1 and 10 is gonna deal with this 199 that's happening. So I'm gonna make my number that's between 1 and 10. I could either do 0.19, 1.99, 19.9. The only one that would work for that is 1.99. So my number between 1 and 10 for that is gonna be 1.99. And just go with this. Once you see a few, I think you'll be fine. And then I'm gonna follow this format, times 10. And now I need to figure out what the power is. This is where people normally mess it up. So the power, I need to map it back to the original number. So right now, my decimal point is right here, and I need it to be back here. So to do that, I need to count my places. So that would be back 1, 2, 3, 4, 5, 6, 7 places in the negative direction because it's moving to the left to get there. Okay, so that means my exponent for this is gonna be to the -7th power. Scientific notation is just a mapping back to the original number. If you keep that in mind, you won't mess up your exponents and get the positives and negatives wrong. So this is the same as 1.99 times 10 to the -7th. Okay, let's do another one. So the next one, number 2, is 24,070. So if I want to make this number into a number between 1 and 10 and put a decimal place in there, where am I going to put the decimal place, or what's the number going to be that this turns into that's between 1 and 10? Do you guys know? You think you know? Okay, so I could put the decimal place in front of the 2. That would be 0.2407. That's not between 1 and 10. I could put the decimal place after the 2. That would be 2.407. Oh, hey, that's between 1 and 10. So I'm gonna purposely put the decimal place right here, 2.407. And I'm gonna let that last 0 drop off because I don't need it anymore. Okay, that 0 was a placeholder, but now that I'm putting into scientific notation, adding an extra 0 in the end isn't gonna be helpful to us. Okay, so now I have a number between 1 and 10 that I've turned it into. I'm gonna do times 10, and then I'm gonna figure out what my exponent is. So currently my decimal place is right here, and I wanna map it back to the original number. The original number's decimal place was right here. So to do that, I'm gonna zoom in so that you can see. If my decimal place is here and the original was here, I'm gonna go right 1, 2, 3, 4 decimal places to get back to the original. So that means that my exponent is going to be a positive 4. Okay, cool. I know it's weird because it's a whole different way of writing numbers. Okay, but it's just always following that format. Okay, same thing with number 3. Number 3, I have to figure out how to change this into a number that's between 1 and 10. If I put the decimal place in front of the 5, 0.59 is not between 1 and 10. If I put the decimal point after the 5, 5.9, oh, that's a number between 1 and 10. So that's what I'm going to go with. I'm going to temporarily put it between the 5 and the 9. And I'm dropping that 0 off now because if I put 5.9 and 5.90, that's the same thing. I don't need to keep the 0 anymore because it was just a placeholder when we were dealing with standard notation. So I put the decimal point here, but the original number's decimal place was right after the 0. Good. So that means I'm going to have to move it right 2 to get back to the original. So that means my exponent is going to be a positive 2. Good. And if you keep in mind scientific notation is just a mapping back to the original, then you'll count your exponents correct and you'll get your positives and negatives right. Okay. Okay. So I'm gonna, we'll do another one. So on this one, if I put the decimal place here, 0.0308, I can't talk, 0.0308 is not between 1 and 10. If I put it here, 0.308 is not between 1 and 10. If I put it here, 3.08, that's a number between 1 and 10. So I'm gonna write 3.08 here. And I didn't keep all the zeros in front because those are just placeholders here. So I can drop them here because they're not necessary. The only reason I wouldn't drop a 0 if it's in between numbers because I still need to keep it if it's in between the numbers. Okay, so now I've put the decimal point right here, but the original decimal place was right there. So if I'm mapping back to the original, I have to go left 1, 2, 3 decimal places. That's left 3. So that's going to be my exponent for this then, times 10 to the negative third. Okay, I see like people are getting this, hopefully, right?
Can you do number 6?
I would love to, yeah. I'm going to skip 5. That gives you guys a chance to try one on your own. Okay, 6, we're just doing it the opposite direction. So this one, they gave it to us in what we call standard notation. That's what you're used to. And we were switching it into scientific. Now they've given it to us in scientific notation and we need to put it into standard notation. So remember, scientific notation is just a mapping back to the original. So all this exponent does is tells us which way to move the decimal place. If it's positive, we move it to the right, and if it's negative, we move it to the left. So right now the decimal place is after the 2. Right now the decimal place is after the 2. And that 6 as an exponent means that I need to move that decimal place right 6. So I'm going to take that decimal place and move it right 1, 2, 3. That gets me to right after the 5. And then I'm going to do 4, 5, 6. And I'm going to add in those zeros back in now. So that means that this number in standard notation is going to be 2,105,000. Okay, let's do a couple more. So the next one, the decimal place is between the 1 and the 9, and the exponent is a 4. Does that mean I need to move left 4 or right 4? Good, that means I need to go right 4. So the decimal place was here, and I'm gonna go right 1, 2, 3, 4, right? 1, 2, 3, 4, yeah. So I'm gonna add in the zeros. That means that This number in scientific notation is the same as 19,900 in standard notation. Okay, and if you want to rewrite it without the like curves underneath, that's fine. I think the curves get distracting. So I'll normally, when I do this, I'll rewrite them out to the side. That way it doesn't look so weird. Okay. Okay, let's do one more together really quick. So the decimal place is between the 7 and the 0 right now. And this says the exponent is -3. That means left 3. That means left 3. So if the decimal point was here and I'm moving that left 3, that's left 1, 2, 3. That means I need to add 2 zeros to the front. So that means that 7,006 times 10 to the -3rd in scientific notation is the same as 0.007006 in standard notation. Cool? Okay. I'm gonna leave this up and I want you guys to then try to do 9 and 10 without me, okay?